So one of the things that I've realized that the textbook doesn't talk too much about in Chapter 4 is how to tell if an acid is weak or strong, or a base is weak or strong. They give you a list to memorize, but they don't really talk about why or how to tell. So I wanted to give you a couple tips. And they're not great rules, but they're at least some help in trying to kind of categorize some of the things in your minds. So let's look at strong acids. And I've got two kinds of acids written down here. These are the two kinds that we really have information, some kind of guideline about here. So hydrohalic acid, that means hydrochloric acid, hydrobromic acid, hydroiodic acid. If you look at the halogens, that's where the halic in the word hydrohalic comes from. If you look at the halogens in our periodic table, we have over here, we have the very last group is the noble gases, and the one right before it, that's our halogens. Okay, all of the hydrohalic acids are strong, except for the very top one, hydrofluoric. And so if you look up here, the very top halogen, at the top of the halogens, fluorine, that's a weak acid, HF, hydrofluoric acid. The rest of them are strong. So not much of a rule, but hey, it helps a little bit. All right, oxoacids, this is a little more helpful. I kind of think this is a neat rule, pretty helpful one, and that is, let's look at something like H2SO4. We're going to look at the number by the 2 and the number by the 4. The difference between these two numbers, if it's 2 or more, then if the oxygens outnumber the hydrogens, I should say, by 2 or more, then we are a strong acid. If, on the other hand, we have something like H2SO3, sulfurous acid instead of sulfuric acid, when we look at these numbers, 2 and 3, we come up with only 1 in between, and so therefore it's a weak acid, so it belongs over here in our weak acid column. Let's look at phosphoric acid. Oh, phosphoric acid, 3, 4, that's a 1, so we can't put it over here. We have to move it over to the side, H3PO4, because the difference being 1, that's less than 2, not enough. Let's look at the chlorine-containing oxoacids. So HClO3, now that would work, wouldn't it? That's 2 or more. And HClO4, oh, there's 3, that would work, but HClO2, there's only a difference of 1, that's not enough. And HClO certainly won't work because the difference is 0. So we just subtract the number of oxygens minus the number of hydrogens in the formula, and it tells us whether the acid is strong or weak. I just think that is a very cool rule because I guess because I didn't know it when I was a student and I just had to memorize them, and I think this is nice to have at least some kind of a rule. Okay, so let's move to strong bases and weak bases. And this is not too hard either. If we have an OH or an O in the formula, if we have hydroxide, something hydroxide or something oxide, so KOH or K2O. So this is potassium hydroxide, potassium oxide. Any hydroxide or oxide will be a strong base. If we move over to the weak base side, ammonia, NH3, is a weak base, and any nitrogen-containing compound where we have a lone pair on the nitrogen. So, for instance, if I put a C with 3 H's on it, and then I attach that to a nitrogen with 2 H's on it, I'm going to have a lone pair on the nitrogen. That'll be a weak base. So pretty much, as you see these things, here's another option. I could put 2 CH3 groups on that nitrogen. My lone pair is still there, and I only have 1 H. But those are all going to be weak bases. And on you can add various amounts of numbers of carbons in these chains and various things, but as long as there's a lone pair on that nitrogen, it'll be a weak base. To finish up, let's talk for 1 second about what the difference is between a strong and a weak acid or base. When we talk in daily life about the terms strong and weak, we're talking about concentration, right? Strong coffee is very concentrated coffee. Weak coffee is dilute coffee. Same with tea or anything else you're drinking, lemonade, anything. But in chemistry, we don't use those words to mean that. So we can have a strong dilute. I'm going to make a little chart here. We can have a strong dilute acid or a concentrated a concentrated strong acid. Sorry, I was busy drawing and not thinking about what I was saying. Okay, so let's say, what is an example of a strong dilute acid? Well, a strong acid is anything in that left-hand column, so let's just pick HCl. If it's dilute, it means its molarity is really low, like 0.1 molar. If I have 12 molar, however, that's very concentrated. I have lots and lots of the HCl. Oh my goodness, I've got an alarm going off on my phone here. Let me silence that. Ha ha ha. I got to be somewhere in half an hour. Okay, sorry about that. We have dilute acid, concentrated acid based on the concentrations, but the strong or weak is based on their identities. So let's put HF here. If I had 0.1 molar, I would be dilute and weak. And I don't know what we would pick here. We could pick just any big number, 6 molar HF. If we could do that, we would have a concentrated weak acid. Acetic acid is a very common acid. Oh, I should mention that. Also on the weak acids, let's put a little extra box over here and say organic acids are weak. And the way you know something is organic is it has carbons in it, like C2H3O2 is acetate, put the H on the front and you have acetic acid. If you have more than one carbon in there, it's always going to be weak. And another thing to know about this is that you will often see them written differently with the two O's and the acidic H stuck out on the right end of the thing. So organic acids can be written with the acidic H at the beginning of the formula or at the end of the formula here. They both mean the same thing. This is the typical organic chemistry way of writing it, the lower one. And this is more of a little summary of just what's in it. But we do at least separate the three hydrogens that aren't acidic at all with the one that is weakly acidic and put that one out the front. So organic acids are always weak, and that's another rule that is helpful.